Throughout human history, we have been awed by the aesthetic qualities of nature. However, we have very little understanding of the underlying function and importance of natural systems. These natural systems, which have evolved over thousands of years, are far more capable than any engineered solution. This makes the integration and propagation of these systems integral to developing a successful community design. Wetlands are one of nature's most versatile tools. Through a process known as the nitrogen cycle, harsh compounds are broken down by bacteria and reconstituted as nitrogen, one of the primary nutrients for plant growth. Also, during heavy rains, wetlands are able to absorb much of the floodwater without the need for levees or dams. Finally, wetlands provide a robust habitat for hundreds of species and are crucial to migration flyways. Plants themselves serve our environment by absorbing carbon dioxide from the atmosphere and converting it into oxygen and new growth. Even the limited amount of rain received in Southern California serves multiple functions. As the rainwater rushes downstream, it deposits a new layer of nutrient-rich sediments, which are critical to healthy plant growth. Because of the capabilities of these systems, they are the foundation of the PostOP framework. The site chosen for PostOP is a 3,000-acre tract of undeveloped land 30 miles east of Los Angeles. The area is largely defined by a seasonal wetland across the majority of the site. This unique attribute has made it unfavorable to the traditional community model, making it one of the few areas in the region untouched by sprawling development. The site itself is a part of the Santa Anita River watershed, the largest river and creek system in Southern California. The Santa Ana River and its tributaries make their way from the San Gabriel Mountains to the north, through Prado Dam, and into the Pacific Ocean. Although water does flow year-round, over 2/3 of the annual rainfall falls between January and March. This seasonal flooding led to a disastrous flood in 1938, which destroyed over 5,600 homes. The response was to build Prado Dam, seen here. Constructed in 1941, the dam's construction drastically changed the character of the area upstream. Unlike most dams, which have deep lake-like reservoirs, Prado Dam has an expansive wetland area of over 10,000 acres with a shallow average depth. As a result of Prado Dam, this reservoir became the largest wetland in Southern California. The impact of Prado Dam on the PostOP site, roughly 3 miles north of the dam, is the transformation of a riparian corridor into a seasonal wetland. In addition, the dam would submerge the majority of the site during flood events. This topographic model shows the waterline on the PostOP site during a normal seasonal flood. Here, during a 100-year flood, and a 250-year flood. In response to this, PostOP has been designed so that no permanent structures are sited inside the flood zone. Also, the size of the wetlands will be expanded, allowing for segments to provide filtration and purification year-round, as well as increase the wetland's capacity for floodwater. This increased filtration capacity helps to alleviate one of the major concerns facing this waterway, urban and agricultural runoff pollution. Although the overt dumping of toxic materials has been stopped, there are still many substances that end up polluting our rivers. Oil from engines, rubber from tires, and pesticides and fertilizers from farms all end up washing into waterways. To prevent this in PostOP, all runoff created by the community will be contained and treated before being allowed into the river. In addition, the creation of an extensive bike and hiking trail system through the wetlands allows visitors to appreciate its natural aesthetic beauty, as well as witness the systems functioning firsthand. By preserving and expanding the natural systems already in existence, PostOP will improve the health of the local ecology while simultaneously processing the community's waste and providing the nutrients needed for the site's agriculture. These natural systems provide a sustainable foundation on which the remainder of the community can be developed.